In this video, we're going to take a look at integer exponents. We'll get into negative exponents. We won't get into fraction exponents, though. That will be coming in another chapter, really. And by the end of this week, we'll be into the point where we review for our first test. So let's take a look at integer exponents. Integers meaning things like 1, 2, 3, but also negatives, right? Negative numbers are integers as well. So a negative exponent basically means that whatever term you have wants to move. So x to the negative n means that it wants to move from the numerator to the denominator. If it's 1 over x to the negative n, it wants to move from the bottom to the top. And there are cases where they're both negative. So look at this case over here. That exponent on the top is negative, and that exponent on the bottom are negative. So the x to the negative m moves down, the y moves up. Now you notice when it moves, the sign changes. So in this first one, it was x to the negative n. When it moved down the bottom, it became positive. Same type of deal over here. When it was negative on the bottom, it became positive on the top. So anytime it moves, the sign of that exponent changes. So it becomes x to the positive m on the bottom, y to the positive n up on the top. So why does this work? How is it that we can do this? Well, think of these numbers like 3's, right? 3 to the third is 27. 3 squared is 9. 3 to the first is 3. 3 to the 0 power is 1. What is 3 to the negative first? Is not a negative number. 3 to the negative first means I want to move it from the top of the fraction to the bottom. And when I do, it now becomes 3 to the first. So 3 to the negative first is 1/3. 3 to the negative second power means it wants to move from the top to the bottom. So when it moves to the bottom, it becomes a positive exponent. 3 squared is 9. So 3 to the negative second is 1/9. How about 3 to the negative third? You start to see the pattern. 3 to the negative third is 1 over 3 cubed. So 1 over 27. So part of my point in doing this is that you notice that even though you have negative exponents, that doesn't mean that the answer is negative. It can be, right, if there's a negative in front of the problem. But here, a negative exponent does not mean that the answer is negative. It means that the answer is a fraction. What about on this other side? I have 1/2 to the third. Well, 1/2 to the third simply means that I cube the top. Well, 1 cubed is just 1. Cube the bottom. 2 cubed is 8. So 1/2 to the third is 1/8. You might imagine if I had 1/2 to the second, I'd have a quarter. 1/2 to the first is just 1/2. 1/2 to the 0 power is 1. But what happens when I get down to the bottom? What happens when I have a 1/2 to the negative first? What that means is that whole fraction flips. Instead of 1 over 2, it becomes 2 over 1, and the exponent is now positive. So 1/2 to the negative first is 2. What's 1/2 to the negative second? If you don't like flipping the fractions, you could always think of it this way. Think of it as 1 to the negative second over 2 to the negative second. So that 1 to the negative second moves down to the bottom as 1. 2 to the negative second moves up to the top as 2 squared, which is 4. And now you might have guessed 1/2 to the negative third is 8. So again, there's no negative numbers here anywhere as the answers. All those negative exponents do is they shuffle the numbers from top to bottom, bottom to top. All right, so let's try simplifying a few of these. There's a lot of these in these PowerPoints. We're not going to do all of them, but at least we'll handle a couple of them. Take a look at number 2. Number 2 is here for an important reason. It's got a 2x to the negative third. You notice that negative third power only applies to the x, not to the 2. So the 2 stays right where it is. The x to the negative third moves from the top to the bottom. When it moves to the bottom, it becomes positive. If I had put that thing in a set of parentheses, if I had put in 2x to the negative third like that, then it would apply to both the 2 and the x. But here, it's not, so the 2 stays on the top, the x moves down the bottom. Look what happened to number 3. I've got an a to the negative second and an a to the negative seventh. So let's try to get rid of the negatives. Move the a up at the top. Move the a to the negative second down the bottom, becomes an a to the positive second. But now, where do I have more a's? I've got more a's on the top. How many more? 5 more. You could have used a rule that says take the top minus the bottom, and that would have worked. In fact, we'll go through it in a little bit, but sometimes flipping them and getting rid of the negatives are just as good. How about number 5? Number 5 is the same base, so same base add exponents. So you'll end up with an x to the negative 3 minus 5. So x to the negative 8th. Now you notice the direction said answer with positive exponents. So answer with positive exponents is my way of forcing you to put these things in fraction form. So x to the negative 8th becomes 1 over x to the positive 8th. All right, look at number 7, a plus b to the negative 5th. Well, I can drop that whole thing in the bottom of a fraction as 1 over a plus b to the 5th. And I'm just going to leave this. I'm not going to multiply a plus b times itself 5 times. So I'm just going to leave it as that. All right, how about number 8? Both of those terms get raised to the 5th power, so maybe I want to simplify it a little bit first and end up with x to the negative 15th, y to the negative 20th. And then I can write it as 1 over x to the 15, y to the 20th. All right, look at number 10. 1 positive and 2 negatives. So the positive goes up on the top, right? A to the 6th. B to the negative 2nd drops to the bottom as b squared. C to the negative 4th drops to the bottom as c to the 4th. Okay, there's nothing else to simplify there. Look at number 11. Maybe the first thing for number 11 is to move these terms where they want to go. So the 3 stays right where it is. This x to the negative 4th can drop down to the bottom of the fraction as x to the positive 4th. There's already a y to the 3rd there. Look at this y to the negative 2nd. Drop it down to the bottom as y to the 2nd. So I end up with a 3 on the top and an x to the 4th, y to the 5th on the bottom. All right, one more. Let's tackle number 9, because number 9 has a coefficient in it. Notice that there's a negative 2 that's raised to the negative 3rd power. So I have a negative 2 to the negative 3rd power. I've got an a to the negative 4th to the negative 3rd power. And I've got a b to the negative 3rd power. So negative 2 to the negative 3rd means 1 over negative 2 to the positive 3rd. A to the negative 4th to the negative 3rd, power to a power I multiply. So negative 4 times negative 3 is positive 12. And then b to the negative 3rd, drop it down the bottom, change the sign. How do I simplify this? Well, negative 2 to the 3rd means negative 2 times negative 2, which is 4, times negative 2 is negative 8. So on the bottom of my fraction, I've got a negative 8. I've also got a b cubed. What do I have on the top? An a to the 12th. That's how I simplify this thing. All right, so keep track of whether things are in the parentheses or outside of the parentheses. And also for the negative signs, keep track of whether the negative signs are in or out of the parentheses. All right, I had hinted a little bit ago about the quotient rule. If you've got two terms that are the same, different exponents or even the same exponent, the way you simplify it is keep that term, do top minus bottom. Now, I broke this into two parts because the textbook does. Really, it works whether the exponent on the top is larger or the bottom is larger. The only difference is you might get a negative instead of a positive. And I made a little note down the bottom that anything to the 0 power is 1 except for 0 to the 0, which is undefined. So why do these rules work? Suppose I have an x to the 8th over x to the 3rd. How is it that I can just take these two exponents and subtract them? How is it that I can just make it x to the 8 minus 3 power? 8 minus 3 is 5, so x to the 5th. Why? Well, suppose I wrote out x to the 8th. X to the 8th is just x times itself 8 times. Down the bottom, x to the 3rd is x times itself 3 times. And I start canceling. One x top and bottom, another x top and bottom, another x top and bottom. What am I left with? I'm left with 5 of them. Even if I had something like x to the third over x to the third, what would that be? It would be x times x times x over x times x times x. Everything cancels top and bottom, so I just get 1. If I did this with my exponent rule, I would do x to the top minus bottom power, which is just x to the 0, which, as long as x is not 0, gives us 1. All right, so let's take a look at these. Take a look at number 3. For number 3, we've got a y to the third over y to the 8th. So we can look at this in 2 different ways. If we want to stick strictly with positives, we could say I've got more y's on the bottom than on the top. How many more? 5. So in other words, 3 of the y's on the top will cancel 3 of the y's on the bottom. I'll get 1 over y to the 5th. Another way to look at this is I can still take top minus bottom, right? I'll get y to the negative 5th. Y to the negative 5th is the same thing as 1 over y to the 5th. So you can still use the top minus bottom rule. You don't even have to think about whether the top is bigger or the bottom is bigger. It's just that you might end up with a negative exponent. No. Turn it into a positive exponent if that's what the question asks for. All right, take a look at number 5. Number 5, we've got a constant and 2 sets of variables. So we're going to evaluate the constant first. Negative 12 divided by 6 is negative 2. Okay, let's take a look at our x's. We've got 2 more x's on the bottom than on the top. So we could do x to the 8 minus 10, right? Top minus bottom will give us x to the negative second. So we'll put it down the bottom as x squared. Look at the y's. I've got 3 on the top. I've got 1 on the bottom. 3 minus 1 is 2. There's my answer. Can't do anything more with that. Nothing's a like term. All right, take a look at number 7. I've got a 30 and a 15. So those are my coefficients. Those are the things I'm going to divide out first. So negative 30 divided by 15 is negative 2. X to the 0 is just 1. And there's no x's on the bottom, so actually I'm done with that. Look at the y's. 1y cancels top and bottom. I'm done with those also. And then for the z's, there's 1 more z on the top than there is on the bottom. So I end up with just negative 2z as my answer. Done. All right, look at number 9. Number 9 has a's and b's. If you want, if it makes it a little bit easier, figure out where those a's and b's want to go first. Well, first of all, 2 over 6 is the same thing as 1 over 3. So let's get rid of that. For the a's, I've already got 5 a's on the bottom. These want to move to the bottom as well. When they move to the bottom, they become positive. I've got a b to the 6th on the top. That b to the negative 4, that negative exponent means it wants to move, so it moves up to the top as a positive. So now I've got a b to the 6 times b to the 4. 6 plus 4 is 10, right? Same base, add exponents. Now we're going to start combining our rules together. On the bottom, 2 a's, a to the 5th, a to the 3rd. So there's 8 of them altogether. And there's my answer. Number 10 is pretty simple. Negative exponent means flip. So I get an a to the 3rd over 3, now raised to the positive 2nd power. Okay, gives me an a to the 6th on top, 9 on the bottom. All right, take a look at number 11. Number 11, you notice the inside terms are the same, but one is raised to a negative 3rd power, one's raised to a negative 4th power. So maybe I can flip them. Maybe I can make it a 3xy squared to the 4th on top, right? So that negative 4 on the bottom, when I move it to the top, becomes a positive 4. And when I move this guy from top to bottom, again, he becomes positive. So I end up with a 3xy squared to the 3rd. Well, now I have 4 of the same term on top. I've got 3 of the same term on the bottom. So 3 of them will cancel top and bottom, and I'm left with a 3xy squared to the first, but I don't have to write to the first power. All right, one more and then we'll wrap this one up. Let's take a look at 13. For 13, first thing I might do is simplify the insides. So you notice I've got an x to the third on the top and an x on the bottom. So there's 2 more x's on the top than there are on the bottom. So I got an x squared. Notice this y to the 0. Y to the 0 is just 1. So that'll give me just a y squared on the bottom and no y's on top. And then a z squared on the bottom. So it's this raised to the negative third. So maybe we didn't exactly clean it up completely, but at least it looks a little better. Right, negative exponent means flip. So I put my y squared z to the second on the top, and my 3x squared goes on the bottom. Now when I raise this, I'm going to raise it to the positive third power, not the negative third power. And now it's just a matter of multiplying exponents. So I get a y to the 6th, z to the 6th on the top. On the bottom, don't forget 3 to the third is 27, x to the 6th. And there's my answer. All right, we'll wrap this video up and we'll do scientific notation in the next one.